we'll start with Mark, because Mark has another task right after. He has to move fast. Okay, Mark, so you'll be the first, and then we follow the program. If someone wanna have a program, is here, okay? The idea again is to give you an overview of activities and find some connection, and for all of you to know a little bit more about part of the department and part of the graduate program activity. Okay?
Ladies and gentlemen, thank you, Professor, for the opportunity to be here. Sorry for my delay. I prepared for travel and I have 25 minutes to pick the car. Let's see. I'll give a very short overview of some works that have been carried out on this level, GNSS and machines that I'm planning. And receiving work that I've been carrying some cloud writing, not entirely here at the university. I've been starting with that overall. But I will give a quick introductory of the, let's say, problem definition when we talk about machine damage on crops. When we think about the financial damage, we can say that the cost of machinery is responsible from 10 to 20% of the cost production of animal crops. Many times this is equal to fertilizer. So when we talk about using our fertilizer more wisely, or even use variable rate, aiming to achieve better efficiencies of machinery, we will have like sometimes similar, maybe even more benefits towards that. Specifically this crop here, and this is one of the reasons why I come back to Brazil to work with that money, because sugarcane in specifics has 40% of its full cost, full crop production cost related to machinery. I will give you more or less data about that, but it's very significant and there is a lot of room to improve regarding that. When we're talking still about machine damage, we talk about undesired traffic. We're talking about two main results of the undesired traffic is the overrunning of crops and soil compaction. Overrunning of crops is a big issue. I would say people usually say, okay, it's a very big issue in sugarcane. This is why sugarcane is adopting more CTF, control traffic farming. But nevertheless, I will show you a few images I have here. I hope it will be visible for everybody to see that even in our annual crops, it's becoming a problem. Maybe when it comes to this soil compaction. A few trends that we've been observing here, like when it comes to GNSS controlling machinery. In this case, I put an example of non-controlled GNSS controlling machinery. We have the control traffic farming, and a few countries are leading this kind of technology, which is not us. It's pretty much Australia. Australia, the adoption of control traffic farming is increasing a lot on crop production in general. And Brazil is following this trend for sugarcane, mainly because so far the concern is not about CTF and soil compaction. It's far more regarding the overrunning of the sugarcane ratoons, because those ratoons are planted once and they need to grow 5 years in a row. So if I accidentally or non-desirably drive upon those ratoons that I just harvested, I will damage them, they will not grow back. So it answers for a few reasons why sugarcane is the biggest adopter of automatic pilots within the country. When we talk about robotics, it's pretty much more an international trend. It's not really Brazilian so strongly so far. I gave here a very example of a stupid robot here that has no actually GNSS guidance. They just go randomly on the field, cutting the grass. And until they cut the full area, because they go randomly, they go from this side, hit here, hit here, hit here, go like this. So until they cover the whole terrain, they pass close to 15 times the same spot until you can reach the whole terrain. So this is not what I call stupid, it's just because it has no intelligence embodied in it regarding the path it follows. Financially speaking, this is the reason actually why sugarcane is let's say, the apple of the eye of automatic pilot in Brazil. It's like, why? This machine here, both this machinery here, they run 24 hours a day. So the pilot here just goes out, another pilot takes control every 8 hours. It just does not stop. And it takes time, 9 months a year. I mean, maybe somebody can come with an example, but I don't see any other machine that's so much used only. These machines, they easily get to the use of 3,000 hours per year, which is like not even close to other machines that we see around. And despite this machine costs the same as a very huge combine harvester, it's capable of only carrying 1.5 meter width. The width of work of this is 1.5 meters, so it explains, and it's harvesting a huge amount of biomass. So it explains why the field coverage, the coverage of this machine on the field per day is quite low. Efficiencies, and the problem of this is also efficiency, because it's usually harvesting a high amount of biomass. This tractor, at a certain point, is full, have to go away, the machine sometimes is waiting, and very often the maneuvers done by this, mainly by this guy here, take very long. Sometimes they're taking about 1 minute for this machine, for this specific type of machine, to go back parallel to the harvest to start again a new row. So we reported, efficiencies were reported that from 24-hour shift of work, in total, only 8.5 hours were really net profitable of work. So we're talking about a huge increase in efficiency, less than 40%. When we come about undesired traffic, there is a lot of numbers here. I would like to point here what was recently done. We have like sets of sugarcane plant rows and the crossing of the harvester and the tractor carrier. The margins that we have for avoiding damaging the ratoon are very narrow here. We see like here coming to 16 centimeters here from both sides. Here we have like an example of tractor carrying going like 33 centimeters at the side, already damaging a big part of the ratoon. Can you imagine this being done during the night, because it's 24-hour operation, it doesn't stop, and still it's getting like, any offset of this is just damaging everything that's happening. So you can understand why 39% of the sugarcane mills already adopted automatic pilot in Brazil. So during the day, during the night, they are trying to keep as much accuracy as possible. The question that was like within us is what is the accuracy level are we achieving? Oh, when it comes to overrunning of crops, I'm giving here an example of soybeans. Soybeans, you say, okay, soybeans, I don't have the problem of growing next year from December to, but I'm leaving a footprint. In here is a direct damage of the overrunning of crops is like tracks of a sprayer that are going across this here. This damage of, are you kidding me? Wow. This damage here is about 5% of the crop. When you have a sprayer room of 20 meters, 5% of your crop is being overrun every year. We're talking about a 25 million hectare covering crop in the country. So we can imagine that 5% of all this thing is just being overrun. So the issue of, but more than that, I hope it's visible here. I don't know if I can prove it, I'm not asking you to have faith, only if you really can see. In here, there are like 2 tracks. These 2 tracks are not the tracks that the machine used to spray. Those are soil compaction caused by the spray of the previous year. So we are having already damage on the crop created here by soil compaction. We are very proud to institute non-tillage system in Brazil and the benefits it brings to soil, but inside crops so far, if I can ask only, I see very few, if no farmers at all, really applying controlled cropping farming system. Not even close to what is being done in Australia and other countries. Technologies are available. We see this guy not touching the steers here, so, And this is already a picture taken like in 2008. It's in a very countryside of Brazil, so we see that technology is already available for a long time. When it comes to designing your path and covering the field in a very good accuracy. A few benefits of the automatic pilot here, I will just give you very quickly, like, here's a sugarcane. This data was presented also in the video conference. Regarding, for example, the harvester, the manual harvester guidance compared to the tractor manual guidance. How much we're talking? We're talking about around 28, let's say around here, sorry, I could not keep the graphic straight in a row. But around here, from this point on, you're only creating damage into the rotunda. So this percentage, this sum percentage here, will create only damage. Using only manual guidance of the harvester and tractor. When we put RTK auto guidance on the harvester, the tractor got improving in its manual guidance as well. Probably the guy is following the combine more accurately. So even if one of these machinery, at least the harvester, uses auto guidance, we already have an improvement on the accuracy. And when harvester, RTK guidance, and tractor, RTX guidance, are embodied, so we have like pretty much no damage on the rotunda whatsoever, at least in that system that we observed there. Well, this is a bit of a contrast of what the work they have done here, which is of course far more accurate and far more nice to see, is that when you presented data on the RTX was the opposite. The industry was very unhappy because it was like less than 9 centimeters offset along tracks measured 10 months after. So, contrary to one presentation followed by another, and they presented something that the dealer didn't like, and suddenly we present something that the dealers did like. But the method of measurement that they use is far more accurate than we use here. But so far, the method developed here is being like, we're being quite optimistic that we will use it more. Path planning, pre-planning, and in Brazil we have a very nice name for that called systematização, systematizing. So I'm just giving an example of what is the issue of path planning usually take abroad, outside of Brazil, which is trying to find the most efficient path, direction of field, and types of turning. This very figure here is already been published in the Precision Agriculture. From a work that has been done trying to optimize not only the number of turns but also the type of turns that can be done in the field, with very significant results. But the problem in Brazil is pretty much this. We cannot just choose the direction of work, we must follow a certain level line. The problem of following a level line is very often you have this kind of things. The level lines are never parallel, as you can see here. When they are not parallel and you are trying to follow them as accurately as possible, you end up with these narrow roads. In the middle of the field, they create a huge damage and efficiency, and also the overrunning forms. So the requirements for establishing good path planning will be at least taken in this work is regarding steerability, erosion issue, and efficiency. I will just take time to make a quick demonstration of what we have been working here. But wait a minute. I will skip already. There is already a tool developed that can plan paths. I will already skip to a tool that is capable of evaluating the paths. Wait a minute. Pretty much in here we have like a tool that was developed capable of, you can load scenarios of path already created. I'm loading a specific one here. For example, here I have a scenario of a field in which I selected a number of tracks which will cover this field. And I can select one of these tracks and see, okay, let's see, an idea of efficiency. In a 21-meter track, I have so number of passes. In a 3-meter track, so this amount of passes. But when I load the data elevation model to it, I can discover more things about this, like this first track here. I can discover that within the path, where will be the highest places where my path will be higher slope. If Following that path, there will be places with more slope and less slope, and this is a very important data for me to know. Along with that, the very important data is the view of the water flow. If I have a huge length of water going in the direction of another huge length of water going to the same direction, I probably will have a value formating in the center of that, because the water will overflow, cross the lines, and just go downhill. And in here, despite these two tools here, seeing the slope or seeing the view of the water flow, it's important. We cannot really still estimate the potential of erosion in the area. So, adopting some ESALQ parameters, rainfall, soil type, cover management, and erosion containing practice factor, we can here now calculate. Also, for example, imagine for this scenario here, how much erosion will it still measurable here. So here is an area with huge potential erosion, with a mean in this full area, full soil loss per year, 18.5 tons of soil loss per year. If I work in this direction, if I change to a more conservative approach, I can decrease this to 14.3 tons of soil loss per year per hectare. And if I choose another path, I can reduce this maybe even more, to 13.4. If this is still not enough, what I can do as a decision maker is just change the time of the year in which I want to put this crop on field. Is there a month with lower rainfall, March, for example, for us? I can just readjust and recalculate if the soil loss will be, look, 2.86. So I can adjust not only as decision making the spatial position of the spatial soil loss, but also the temporal. I can manage the soil loss by the two factors. Likewise, the small field here, take a short example. This goes. Also give an estimate, quite low soil loss level. So, there is another tool behind this capable of preparing all these scenarios in a very fast manner, but given the time, I'm presenting this one. But regarding, sorry for the time, maybe I skipped a few minutes. Yeah, not much more to say. Actually, I believe the time for questions will be taken now or later. Right now, okay. People, whoever has questions, please feel free. Sorry, maybe I spoke too fast. Yeah, go ahead.
So your calculations are based on the universal soil.
Exactly. Based on parameters extracted from that. So when you have an increasing slope and length, it will calculate specifically how much soil loss by year.
Elevation data, where you have that data elevation model.
The data elevation model in this case, what you see is just by a sensor running in the field with an, in this case, I cannot promise the accuracy of this, is an SF2 guidance system, which we will log in the position of data along with the output. But of course, we can nowadays there's plenty people that work with tracking data from RTK systems already embodied in the combines. So for them, this data is already available free.
So no problem to get this data.
No. We don't have any issues whatsoever. Okay. Gentlemen, sorry for the fast speaking.